Okay, this video is for help on the study island topic, rational approximations. So what's going on with rational approximations? What this lesson is about how you get close to the value of the square root of a number that's not a perfect square. So you've been doing square roots before. So for example, if I gave you, say, the square root of 36, you know that the square root of 36 is 6 because 6 times 6 is 36. You know the square root of 25 is 5. You know the square root of 16 is 4. You know the square root of 9. The square root of 9 is 3. The square root of 4 is 2. And the square root of 1 is 1. So these ones are easy. 6 times 6 is 36. 5 times 5 is 25, etc., etc. So these numbers, 36, 25, 16, 9, 4, and 1, are perfect squares. And they have square roots that are whole numbers. Well, what happens if I ask for the square root of a number that wasn't a perfect square? For example, what if I said, hey, what's the square root of 30? Well, the square root of 30, no number times itself, no nice round number anyway. No number times itself that's nice and round and easy. No whole number times itself equals 30 when you multiply it by itself. But what do I notice about the square root of 30? Well, if I just use some common sense, I could say the square root of 30 is more than the square root of 25. And the square root of 30 is less than the square root of 36. That seems to follow common sense because 30 is less than 36 and 30 is more than 25. So the square root of 30 is less than the square root of 36, and the square root of 30 is more than the square root of 25. So if I were going to write that in kind of a line, I might say something like the square root of 25 is less than the square root of 30, and that's less than the square root of 36. Well, I know what the square root of 25 is. The square root of 25 is 5. And I know what the square root of 36 is. The square root of 36 is 6. So if I ask you, what's the square root of 30, you may not be able to give me an exact answer, but you should be able to approximate. You should be able to tell me that it's somewhere between 5 and 6, because 30 is in between 25 and 36. So that's a big part of this whole lesson. It's just figuring out, if you're trying to take the square root of some number, what two perfect squares is that number between, and what are the square roots of those two perfect squares? 25 is a perfect square, 36 is a perfect square. The square root of 25 is 5. The square root of 36 is 6. So the square root of 30, being between the square root of 25 and the square root of 36, must be between 5 and 6. So let's go ahead and take a look at this first question here. It says, at what point on the number line is the red dot located? Now, it's kind of hard to tell. It's like 6 and 7. It's like not really exactly 6 3/4. It's kind of weird. I just know, hey, it's somewhere between 6 and 7. It's more than 6.5. It's less than 6 3/4. I don't know. It's between 6 and 7. Well, which of these numbers is between 6 and 7? Well, if I were to draw a number line, and I had 6 on that number line, and I had 7 on that number line, could I not also label 6 as the square root of 36? And could I not also label could I not also label 7 as the square root of 49? I figured that out because 6 times 6 is 36, and 7 times 7 is 49. So what does this help us with? Well, the square root of 36 is 6, and the square root of 49 is 7. So that dot, which would have been, around here somewhere, has got to be somewhere between the square root of 36 and the square root of 49, and probably closer to the square root of 49 and the square root of 36, because this dot isn't exactly halfway. It was more than halfway from 6 to 7. If this is the halfway point, it's over that. So let's look at this. Which of these numbers are between the square root of 36 and the square root of 49? The square root of 35? No, that would be over here. That would be on the left side of the square root of 36. The square root of 35 would be over here somewhere. The square root of 90? No, that's going to be way off in that direction somewhere. I don't know, somewhere way over there. The square root of 55, again, that's more than the square root of 49. It's going to be somewhere over here. So this is the only one, the square root of 45. It's the only number that's between the square root of 36 and the square root of 49, the square root of 45. So that's going to be our best guess as to what this is. That's our answer for that problem. Okay, how about this one? At what position on the number line is the red dot located? Well, I'm going to see this dot. Okay, it's a little bit more than 3, but it's way less than 4. So it's between 3 and 4. So again, imagine a number line. If I had a number line and I had 3 on the number line and I had 4 on the number line, 3 is the square root of what? Well, what is 3 times 3? 3 times 3 is 9. So that means 3 is the square root of 9. And what about 4? That's the square root of 16. Because 4 times 4 is 16. This dot's going to be way over here. It's going to be pretty close to the square root of 9. Definitely more than the square root of 9, less than the square root of 16. But because it's so close to our 3, it's definitely going to be closer to the square root of 9 than it is to the square root of 16. So let's go through our options. We got the square root of 5. No, that's not more than the square root of 9. That's barely more than the square root of 4. And the square root of 4 is 2. Pi? Well, hey, pi. What is pi? You know that pi is equal to 3.1415, etc., etc., etc. Pi is an irrational number. So maybe that's it. Maybe they're not asking for a square root this time. They're asking for a different irrational number. Because the square root of 45 is an irrational number. The square root of anything that's not a perfect square is an irrational number, just like pi is. So pi is a little bit more than 3, so that looks like it's a good spot. What about the square root of 2? No. The square root of pi? No. Pi is a little bit more than 3, and that's where this dot is on a number line. So it's looking for pi as our answer. The value of the square root of 22 is between 4.6 and 4.7. Which of the following is a more precise approximation of the square root of 22? Okay, so we've got 4 different options here. 4.68, 4.69, 4.67, 4.68, 4.69, 4.7, 4.71, and 4.72. Now, you can kind of cheat on this, and you can just plug in what is the square root of 22. But what I want to do is show you how they expect you to be able to do it. And I'm going to take a calculator out here, and I'm going to show you how to perform this operation. So here's a calculator. Good old iPhone calculator. So here we go. A, what does A say? It says 4.68 and 4.69. If I said 4.68 squared, and I'm actually going to rotate this so that I have my squared button. If you rotate your calculator on an iPhone, it'll give you some more options. So if I have 4.68 and I multiply that by itself, and that glare is kind of bright, let me see if I can turn that off. So 4.68 squared is 21.90. So it's close to 22. Well, let's try 4.69 now. 4.69 squared is 21.9961. So if 4.69 squared is less than 22, which it is. We got a little less than 22, 21.9961. Then 4.69 squared is less than 22. Then the square root of 22 is going to be more than 4.69 because the square root of 4.69 squared would be 4.69. So it's not going to be between, if I'm looking for what the square root of 22 is between, it's not going to be between 4.68 and 4.69 because it's more than 4.69. So all you're doing is multiplying these values that they give you by each other to see which one gives you the lower end, when you square it below 22, and the next one above 22. So we just checked this first one, and we know the square root of 22 is more than 4.69 times 4.69. So it's definitely not even worth trying B, because 4.67 and 4.68 are both lower, so that's not high enough. Let's try 4.7 times itself. Again, we'll go back to our calculator, 4.7 squared. And there it is, 22.09. So let's write what we just figured out. 4.69 times itself was less than 22, but 22 was less than 4.7 times itself. What that gives us at that point, sorry for the lights, are going a little crazy. What that tells us is if we take the square root of all of these, the square root of 4.69 squared is just 4.69, is less than the square root of 22, which is less than the square root of 4.7 squared, which is 4.7. So I know that the square root of 22 is between 4.69 and 4.7. Now, obviously, the easier way to do this, if you do have a calculator and you're looking for an approximation of the square root of 22, is just take 22, hit your square root symbol, which on your iPhone calculator is this one right here. It looks like a little check mark with the X underneath and a 2 above it. And that gives us 4.69041, blah, 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 blah. This number will go on and on and on forever, forever. No repetition, no ending. So let's go ahead and answer that and do the next one. Identify the missing symbol. Identify the missing symbol. We've got the square root of 173 minus the square root of 6, something compared to pi squared. So are these two together more than pi squared, less than pi squared, or equal? Well, first of all, what is pi approximately? Pi is a little bit more than 3. So if I was going to go ahead and try and do this problem, I've got the square root of 173 minus the square root of 6 is equal to, or not equal to, we don't know what it is, compared to, let's put a question mark here, pi squared. So pi squared, what is pi squared? Pi is a little bit more than 3 plus. So if pi squared is a little bit more than 3 squared, I know that this answer is, or this side of it, is going to be a little bit more than whatever 3 times 3 is. 3 times 3 is 9. So this is going to be a little bit more than 9. So I'm just going to write that as 9 plus. All right. So again, this is approximations. We don't have to be exact right now. We're just kind of getting close. Now the square root of 173, well, let's try and figure out what that is, and let's try and figure out what the square root of 6 is. The square root of 6 is easier. I know that the square root of 6 is going to be between the square root of 4 and the square root of 9. The square root of 4 is less than the square root of 6, which is less than the square root of 9. The square root of 4 is 2, and the square root of 9 is 3. So I know that 6 is somewhere between 2 and 3. Somewhere between 2 and 3. So I'm just going to say, I don't know, maybe a little bit more than 2. I'm just going to write 2 plus. Okay, so I'm subtracting more than 2. Just a little bit more than 2. Not quite subtracting 3. So again, this is kind of a weird way to write it. I'm just approximating here. What about the square root of 173? Square root of 173. Well, if you know your perfect squares, and this is something that really would be helpful for you to memorize, all of your perfect squares, at least from 1 times 1 up to 20 times 20, then these types of problems will be a lot easier for you. For example, 15 squared is 225, 14 squared is 196, and 13 squared is 169. So you know these things, you realize that 173 would fit right in here. It'd be a little bit more than 13. So you've got 13, a little bit more than 13. It's a little bit more than 13, minus a little bit more than 2. So what would it be if it was 13 minus 3? That would be 10, right? Well, this is a little bit more than 13 minus only a little bit more than 2. So we're not going to get to 10 yet. It's going to be more than 10. So this is going to be 10 plus compared to a little bit more than 9. So those are pretty close, but not quite. And again, if you want to double check all these, feel free to use a calculator to kind of make sure that you're getting the right answers. So I know you don't have to do this over and over again, but we can use our calculators to double check and make sure that we're on the right track. So we have 173. We have the square root of that minus the square root of 6. And we get 2.44, blah, 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 and that equals 10.70. And that is going to be compared to, I probably shouldn't have erased that, but 10.70 compared to pi squared, which is only 9.86. So 10.7 is definitely going to be a little bit more. Not by much, but a little bit. After that, determine which two values the following expression is between. So this symbol right there, when you have a square root symbol, but there's a 3 in it, it's not a square root symbol, it's a cube root symbol. And a cube root symbol works exactly the same way as a square root symbol, except it works with cubes instead of squares. So for example, if I say I want 2 cubed, let's say, what is 2 cubed? That's 2 times 2 times 2, which is 8. So if I want to go backwards, I would say, what is the cube root of 8? The cube root of 8 is 2. So that's what a cube root is. Now this one is asking for 9 times the cube root of 29. So what is the cube root of 29? We're going to do this a little bit like we just did with our square roots. What are the perfect cubes? 1 cubed is equal to 1. So 1 is a perfect cube. 2 cubed is 8. So 8 is a perfect cube. 3 cubed is 27. 3 times 3 is 9. 9 times 3 is 27. So 27 is a perfect cube. And you can see right now, oh yeah, 27, pretty close to 29. Then you get 4 cubed. It's 4 times 4, which is 16, times 4, which is 64. So right away, you should be like, oh, the cube root of 29? Well, 29 is really close to 27. If 27 is a perfect cube, then the cube root of 27 is equal to 3. So the cube root of 29 is going to be a little bit more than 3. It's going to be just a little bit more than 3. It's going to be 3 plus. Okay, it's going to be a bit more than 3. And now I want 9 times that. What is 9 times 3? Well, 9 times 3 is 27, so we're going to be doing a little bit more than 9 times 3, so it's going to be a little bit more than 27. And of course, all of these answers are within. So we just have 27.5, 27.6, 27.4, 27.5, 27.6, 27.7, 27.7, 27.8. So all we have to do to figure this out is go ahead and plug those in, multiply them, and see what we get. So to do these, I'm going to go ahead and really just plug in cube root of 29 and do times 9. It's the quickest way to get all of these figured out. How do you find that? Again, on your calculator, you have your 29 and then cube root, which is the little check mark with a little 3. You have 3.07, and then we have times 9, and we get 27.65. So here's 27.6. It's between that. It's more than 27.6, but less than 27.7. And if we were going to go ahead and try and multiply that out, we could multiply our guesses, divide, and we would be able to get the same thing. But in all honesty, nobody really needs to do that. You just kind of have to understand the concept at this point. So moving on. Identify the missing symbol. Well, we have the square root of 26 and the square root of 43. 26 is less than 43, so the square root of 26 is less than the square root of 43. Hopefully that one doesn't require too much explanation. Using number line above to correctly compare the following numbers. 4/3. Well, that's more than 1, but less than 2 because 6/3 would be equal to 2. It's 1 and 1/3, so it's part of the way from 1 to 2. Pi is a little bit more than 3, so that's over there. And then we have the square root of 8. Well, the square root of 8 is going to be a little less than 3 because the square root of 9 exactly would be 3. So if I was putting these on a number line, pi would go just on the side of 3 to the right, and the square root of 8 would be just to the side of 3 on the left, which means the square root of 8 is less than pi. Now that doesn't have it on here. This doesn't say the square root of 8 is less than pi, but it does have that 4/3 is less than the square root of 8. 4/3 is only 1 and 1/3. That'd be way over here on the left side of the number line, away from the square root of 8. All right, let's make this a little easier to see. Place a point on the number line to represent the approximate value of 4 times the square root of 12, round to the nearest tenth. So you just have 4 times the square root of 12. What is the square root of 12? Well, the square root of 12 is more than 3, less than 4. If you have 12 in your calculator and you take the square root of it, 12 square root times 4 equals, and you get 13.85. So again, that's just square root of 12 times 4. So 13.85, take a point. 13.85 rounded to the nearest tenth, it's 13.9. There's 13.5, 13.6, 13.7, 13.8, 13.9. And what is the cube root of 150? So again, easy calculator, 150 cube root 5.31. Okay, make sure that you saw exactly what button I pushed. Again, the cube root button is that one. It's got a little 3 by it. So one more time. Again, I'm sorry for the light. 150 cube root button is right there. 5.31. So it's going to be more than 5, less than 6. Did we need a calculator to do that one? It wasn't asking us to be very specific. We could have figured that out with just a little bit of calculation, a little bit of knowledge of what the perfect cubes are. We've already got the perfect cubes from 1, 8, 27, and 64. If we kept going, we wouldn't have to go very far. 5 times 5 times 5 is 125. 5 times 5 is 25, times 5 is 125. And then you have 6 times 6 is 36, and 36 times 6 is 216. So these are our perfect cubes. 150 fits pretty squarely in between those. So that means the cube root of 125 is less than the cube root of 150, which is less than the cube root of 216. That should be pretty clear because 150 is more than 125 and less than 216. But the cube root of 125 is just 5, because 5 times 5 times 5 is 125. And you've got the cube root of 150 there in the middle, and the cube root of 216 is just 6. So it's going to be between 5 and 6. And last but not least, determine which two values the following expression is between. I have 4/5 of pi. So 4 times pi divided by 5. Also, you can think of it as 4 divided by 5 and then times pi. 4 divided by 5 is 0.8. 0.8 times 3, 8/10 of 3. It's not exactly 3. It's a little bit more than 3. We're getting 8/10 of it. So it's going to be less than 3, but more than half of it. So it's going to be between 2 and 3 somewhere. And yeah. So again, all I did is I noticed that 4/5 is not quite 1 whole. So it's a little less than 1 whole pi. 1 whole pi is just a tad more than 3 because pi is 3.14 approximately. So this is going to be less than 1 whole pi. Well, if 1 whole pi would be 3, it's enough to knock it back into the 2 somewhere, but not so far back that it is less than 2. Okay, so hopefully this was helpful. Let me know if you have any more specific questions, and I'd be happy to hear them out.